be extremely dangerous. How many people know how to make a fire? You always start off with little bits of twig, and you build it up to bigger logs. One of the very problems that happened in mines, usually at the turn of the last century, was the build-up of carbon powder. What happened is the carbon powder builds up. If there was an explosion, we would get a massive reaction. So, I think I better do one. Right, here we have a powder, just like there would be in a mine. You ready?
Yes.
Nothing. It's because there's no air around the powder. And if I put air around the powder, what I can do is create an explosion. So, if I increase the surface area of oxygen around the powder, we get an instant explosion. Now that is because we increase this. Okay, I'll tell you what, give Yasmin a round of applause. We've got the muscles up so much doing that. Thank you, Yasmin. We'll leave that one and we'll come back and we'll do a few more shakes later. Okay? So we've got an explosion here. We have made an explosion because the oxygen goes around all the small tiny particles and makes them combust. And as I say, the mines in the UK, in the USA, Australia, all over the world suffer from explosions just because carbon powder built from the mine shafts used to explode. And that, can you imagine that explosion in a mine trapped underground would be devastating. So when we do powders, when we build fires, we have to be very careful that we don't surround ourselves with powders which can be very explosive. We've seen reactions here. As you can see, this reaction has gone to completion. It went from purple to red. This reaction is changing colour. It's our oscillating reaction. And as we've seen here, these reactions were instantaneous. Some reactions are instantaneous. And what we can do is react just two liquids together. We get an instantaneous reaction, making a beautiful yellow dye, which was used for basis of paint. That was an instantaneous reaction, making some lead nitrate and reacting with potassium iodide. We can also make smoke instantly by taking two chemicals, reacting them together. Can you see them producing a smoke? These particles are coming out of the bottle, reacting in the air, and then moving around. An instant reaction. As we said before, some reactions do take a little bit of time before we see anything. This one is oscillating between being brown and going clear. That's working quite well. If I take these two reactions, the chemical reaction is taking place at the moment. You can't see it. Just keep your eyes on that tube. Can you all see that on here? Just keep having a look. That tube there. See what happens. The reactions take place. Just for those who didn't see it, what I can do through the magic of chemistry is take it back. Are you ready? The reaction was taking place inside the solution. You can't see anything. All of a sudden, it will go. It will go. It will go. Please. It's going to go any minute. Any minute now. go. I promise you, it will go. So, this reaction, as I say, is taking place inside the chemical. We're just waiting for it to react. See it again. Take it back. So as I say, this reaction is taking place. This reaction oscillating all by itself. Chemicals reacting with one species in the pot, then reacting with one species. It's gone again. It's a good one, isn't it? It's called the iodine clock. And you can change it, and it will time very accurately. You can time chemical experiments with it. You can time cooking your egg by it. If you want to. You knew how long in it. Change, you can cook your egg by. Now, we can always make reactions go faster. You want something to... One more. If we want a reaction to go faster, we heat it up, don't we? If we want an egg to cook, we put it in the oven or in a frying pan. We want a cake bake to cook, sit there on a kitchen stove, kitchen worktops, and cook itself. We have to give it some energy. We have to give it either heat or we can use a catalyst. And in science, a catalyst is a chemical that speeds up a reaction but doesn't. Hey, you heard that one? Please, reaction, a round of applause. Now, this is hydrogen peroxide. Hydrogen peroxide is a chemical, and it's used in hair dye, it's used in hair colour, in perming solutions, people who have their hair burnt, and it will break down into oxygen. The test for oxygen is it relights the split. Well, it doesn't, because the reaction is so slow. We need to give it energy, we need to give it a catalyst. And one of the best places to find a catalyst for hydrogen peroxide is in your bodies, in your liver. So here we have some nice bits of liver. We've got the liver in there. It's got an enzyme in it, a violet catalyst. And what we can do is if we add the hydrogen peroxide, the liver starts to break it down a lot more quickly into water and oxygen. And if I put the splint in, it will relight, because that is the text for oxygen. Relights the glowing splint. Now that reaction was okay, wasn't it? Wasn't very spectacular, because I like to make things decompose a lot better. So what I'd like to show you is this reaction. This is called toothpaste. So we bung in some detergent, because this is what I use to go and clean my pet elephant. I've got a pet elephant, he needs his tusks clean every morning. So what I will do is I put some hydrogen peroxide in, and I've got some lovely foaming toothpaste, and I am doing it in the tray because my technician told me to do this in the tray. So it makes a mess. And what we do, we add a little catalyst that will decompose the hydrogen peroxide even faster. And what we're going to do is I need a little toothpaste for my pet elephant. And hopefully, as we make the oxygen, what can you see happening? Is my toothpaste is growing and glowing up my tube. So I've got my big toothbrush at home that I will take, and I've got a pet elephant at home. He lives in the other room. I've got a pet elephant, and I have to clean his tusk every night, and I have to do this reaction every day. So let's just see if we have got